Okay, section 7.4. I'm actually going to do this in 2 videos, but we're only spending 1 day on it. Starting off with defining logarithmic functions. Definition of a log. If we have a log base b of y equals x, that is only true if and only if b to the x power equals y. Okay, b is the base of the log, b is the base of the exponent, okay, x is the exponent, and then y is the argument. In this case, y is what it is equal to. Okay, so that's how logs and exponentials are related to each other. If you're taking the log of some number, you're going to ask yourself the question, b to what power equals y? Okay. Now we're going to switch in between logarithmic and exponential form. This is an essential part because when we get to solving equations, we have to switch between the forms to solve equations. Okay. So here we've got log base 3 of 81 equals 4. So if I want to switch that to exponential form, we start with the base. Okay, so the base is 3. To the power is 4, so 3 to the 4th power equals 81. Okay, 3 to the 4th power equals 81. Coming back the other way, here it's in exponential form. Let's switch it to logarithmic form. So we start by writing the log, and now the base. Well, what number is the base of the exponent? Well, there's the exponent, so there's the base. So the base is the 1/2. Okay, the 1/2 is the base. Now, the argument of the log is what it equals over here. Okay, so log base 1/2 of 32 is going to equal the exponent, which is -5. And then the last one is log base b of 1 equals 0. I left base b as b because any number to the 0 power equals 1. Okay. Evaluate. Let's say we've got to evaluate some logarithms. Okay. You don't use your calculator. I'll tell you why in a minute. Okay. Log base 4 of 64. You ask yourself this question. What power of 4 is 64? So 4 to what power equals 64? What's the power? Well, 4 squared is 16. Okay, it's not that one. How about 4 cubed? Oh, 4 cubed is 64, so the answer is 3. Here's one. Another one. Log base 1/5 of 125. So you ask yourself this question. Okay, 1/5 to what power is going to give me 125? Now, you can't forget about positives and negatives. You can even have rational exponents. So exponents come in positives and negatives and rational numbers. So think about that. 1/5, well, I know 5 to the 3rd power is 125. So maybe 1/5 to the -3rd power is 125. Okay. Next one here, log base 27 of 3. Okay, so 27 to what power is 3? Oh, okay. Let me write it down. 27 to what power is 3? Think about that for a minute. Okay. I do know that the cube root of 27 is 3. Oh, roots can be written as rational exponents. So the cube root is actually what power? The 1/3 power. For example, evaluate log base 7 of 7 to the negative 3x power. Okay? Ask yourself that question. What power of 7 is 7 to the negative 3x power? Oh, I just said it, didn't I? It's kind of redundant. The negative 3x is your answer. Log base 5 of 25 to the x. Well, this one's kind of interesting. 5 to what power is 25 to the x power? Well, I know that 25 is 5 squared, right? So let's rewrite that a little bit. Log base 5 of 5 squared to the x power. Okay, let's rewrite that again. Because this is a power to a power, which means we multiply. Log base 5 of 5 to the 2x power equals what? Oh, wait. 5 to what power is 5 to the 2x power? 2x. Piece of cake. Okay. If this base is the same and then this number, if the base is the same as this number, your answer will always be that exponent. That number, the base is the same as this number, so my answer was that exponent. Seven 5, properties of logs. Here are the properties, and we're going to be using these to solve, simplify, whatever. Okay, we've got the product property. That means where we have two numbers that we're multiplying. Log base b of m times n becomes log base b of m plus the log base b of n. So you can split that up, and sometimes that'll work well for you when solving things. Quotient property. Here we've got log base b of m divided by n. That becomes a subtraction problem. Log base b of m minus log base b of n. Okay. And then one of my favorite ones, the power property. We definitely will be using this a lot with solving. Log base b of m to the n power becomes n times the log base b of n. So that power becomes a coefficient, something you multiply. Okay, let's apply some of these properties right now. And expanding and condensing. Okay, all those properties of logs, it doesn't matter if it's a common log, a natural log, or a log with a base of 18. It can be anything. Okay, the properties are the same no matter what type of log it is. Okay, so if we've got to expand, this is 3 times x to the 4th power. Okay, that's the first thing we do, is we're going to do the product property. So it's going to become the log of 3 plus the log of x to the 4th. Keep going, I still have the power property we can deal with. So that's going to be expanded to the log base 3 of 4 times the log of x. Okay, and then you can also do this in reverse. When you do this in reverse, we kind of have to look at it first, and mostly we're working from left to right. Okay. Here we're going to condense, expand. The opposite of expand is to condense. The natural log of 4 plus 3 times the natural log of 3 minus the natural log of 12. Okay. The first thing we need to deal with is that right there. Okay. We need to take that and make it, it's the reverse of the power property. So we're going to make it the exponent. So it's the natural log of 4 plus the natural log of 3 cubed minus the natural log of 12. Okay. Now we work from left to right. This is going to be the product property, and then it's going to be whatever this is divided by that. So the natural log of 4 times 3 cubed. And you can, if you don't like dealing with my factored version, you want to multiply it out, go right ahead. Minus the natural log of 12. Now this is going to become a quotient, so it's going to be the natural log of 4 times 3 cubed. And we're going to divide that by 12. Okay. Well, when we do that, that's going to simplify to the natural log of 9. Okay. I wasn't asking to evaluate the log, we were asked to condense it, which means to write it as a single log. This one is written as a single log. We're going to expand it, so it's going to be written as the sum or difference of multiple logs. Graphing logarithmic functions. Okay, I've written it here. The easiest way to graph a log function is to use the properties of the inverse exponential. So remember, with inverse functions on the graph, if you've got one of the graphs and if you have one of the functions and you know you have to graph its inverse, the easiest thing to do is to pick a few points and then switch the x and y. That is the easiest way to graph an exponential, or, excuse me, a logarithmic one. Okay, so here's the logarithmic function we are going to graph. Y equals log base 5 of x. The inverse to this is y equals 5 to the x power. Okay, we're going to use this equation to get some points, then we're going to switch them. And then we're going to plot the switched ones, and that's going to be our graph. Okay, so here are the points. Okay, y equals 5 to the x. Well, using our typical negative 2, negative 1, 0, 1, 2, plug them in. Okay, 5 to the negative second power is 1 over 25. 5 to the negative first is 1 over 5. 5 to the 0 is 1. 5 to the first is 5. 5 to the second is 25. Obviously, it's going to be very hard to graph the first and the last points, but we're going to try. We'll just estimate. Probably won't use this last point, to be honest with you. So the points for the inverse function, y equals log base 5 of x, you switch them. Okay? All these y's are now my x's. All the x's are now my y's. Okay? So these are the points we're going to plot. And again, we just estimate 1/25 is very, very, very close to 0. 1/5 is still quite close to 0. And then 1, 0, 5, 1. And then, of course, the 25/2 is way out there, so I'm not going to estimate that one. It's okay if you don't get all the points. I know some of these equations get kind of crazy big numbers very quickly. But there's our graph. And if we were to graph the 5 to the x, the 5 to the x would go up like so. And it has a axis of symmetry of y equals x.